Okay, so hello everyone. So what I want to do in this video, I did do I believe it was a long time ago, or maybe about 2 months ago, I believe I made a video about absolute value functions, absolute value equations, and inequalities. What I want to do in this video though is just graph absolute value functions. I don't want to go over absolute value equations and inequalities yet. I just want to make a video focusing specifically on absolute value functions and graphing absolute value functions. So, I mean, whether or not you did view the video before, it really doesn't matter because, in this video, it's going to be kind of an updated video on that. It was a few months ago, so basically, this is kind of an updated version of that. And this time, except this time we're not gonna do, it's not gonna be as long, right? At least I hope it won't be as long as the last video. It'll just be about graphing absolute value functions. So with that being said, let's get started. So to graph an absolute value function, and one of the things that we have to know is the vertex form of an absolute value function, right? So basically that form is y equals, and I'm going to go ahead and color code this. It's going to be a times the absolute value of the quantity x minus, and then it'll be h, and then plus, and then it'll be k, right? And let me go ahead and put that in a different color, just so that it's kind of diverse a little bit. So like this. So the first thing that I want to go over before we even get into graphing absolute value functions is the idea of actually knowing what the parts of this equation is. So the a, which is this part, this represents the slope. Okay, the slope is just rise over run. And then the h, if you kind of look at the h here, so the h, let me get the right color, represents so the h, I would like to call it the axis of symmetry, but I only say that because this is extremely similar to quadratics. And then this part is k, and it represents the y value of the vertex. Now the vertex should be h, let me get the right color, so h comma k, right? Now, so this is what the form of an absolute value function is, right? And we shouldn't, basically try not to overthink it. This just means that any function that we have will have a v shape, or any absolute value function that we have will have a v shape, and this will be the vertex hk. And the h value is in the x coordinate, and the k value is in the y coordinate. Basically, it doesn't matter if k is negative or positive, you know, but that's just a way of looking at it. Now, so we're going to look at some examples, and I'm going to first try to graph a very basic one, because, well, let's first look at the absolute value of x, actually. And I know I probably did this a few months ago, and I graphed this a few months ago, and but at the same time I want to just, you know, do this again so that those who have never seen that video and who are watching this video can kind of just know what I'm talking about. So let's make this, so let's do 1, 2, 3, and it doesn't matter how many coordinates or how many points, like x and y coordinates it has. The only thing that matters is that we graphed it correctly. So your scale in which you draw your graph with doesn't matter. Usually especially if you're in middle school or in high school actually, and in Algebra 2, they usually give you the graph, but I'm drawing it just for the sake of it. So the absolute value of x, if you want to look at it as an xy table, you can. There's nothing wrong with that. But we want to make sure that we understand both ways, because it's necessary, especially if you are in college. Now, if you don't like doing, if you're in high school and you don't like doing so if you don't like doing, so this is going to be the table form, and I'm going to do it this way first, so that way, you know, hopefully this can help. Now, we have -4, -3, -2, -1, 0, and then it's, should go 1, 2, 3, 4, right? So when we have the absolute value of -4, if we plug that in for x, remember that any absolute value, if we take the absolute value of any negative number, let's name that a, right? Don't overthink that. That just means it's any number a, it's just going to be the positive number. So if I say the absolute value -4, that's just going to be 4, right? So this should be 4. And then the absolute value of -3, that should just be the positive number, right? So it should be 3. If I say the absolute value of -2, that should be the positive number, so it should be 2. If I say the absolute value of -1, that should just be 1, right? The positive number. If I say the absolute value of 0, that's just 0. If I say the absolute value of 1, so now if it's a positive number, it's just going to be the same thing. It's always going to be positive. Anytime you take the absolute value of any negative number, it's always the positive number. So same thing, absolute value of 2 is 2, and then absolute value of 3 is 3, and then absolute value of 4 is 4, right? So then plotting those points, we have -4, so we don't have to go all the way up to 4, but if we, for example, our greatest y term is just, it is just up to 3, and then our lowest y term is down to -1. So we can do just we can plot -3, 3, so it'd be right here, and then you can plot -2, 2, so right here, and then -1, 1, right here, and then 0, 0, right here, and then 1, 1, right here, and then 2, 2, which is right here, and then 3, 3, which is over here, right? And you notice how it looks like a V, right? That's literally what the absolute value function is. That's what it is. It's just a V-shaped graph. This is very similar to the parabola, but we're not really focusing on parabolas here in this video. All you have to really know is that this graph here just represents, it's how you graph an absolute value function. Now, we are going to go over a few more examples in this video where we can do it. So I'm going to do the same example, except this time I am not going to use a table. I'm going to relate it to the form of an absolute value function, right? So let's just look at it again this time. Let's just erase all of this, and let's instead look at it from the vertex form, right? If I say, for example, let's just say y is equal to 1. So let's make this equal to 1 times the absolute value of x, right? If I look at if I look at the vertex, obviously my vertex, I can rewrite this function as the following, right? We can say y is equal to 1 times, or it's going to be 1 times the absolute value of x minus 0 plus 0, right? That's the way you can write it. You can also say plus 0, but because you want it in this form, you would write it this way. That is how you always write whenever you have an absolute value of x. You always write it in this form here. So whenever you just have an absolute value in the middle, and then you don't have any other terms. So here you would say 1 times the absolute value of x minus 0 plus 0. So looking at this, you would ask yourself, well, what is the vertex? The vertex would be, this is h, obviously, if you kind of look at it this way. So that's your vertex, or not your vertex, your axis of symmetry. And this number here, that is 0, is your, so let me actually do it this way. Give me 1 second. So looking at it this way, and I can put 1 as, basically I can do it as in red, right? Just so you guys can see the pattern that I'm looking at this in, right? This is still the absolute value of x, it's just written in vertex form. Now, of course, you wouldn't do that. If it helps, you can, but, if you can look at it this way as well, and you can say, well, the vertex is just hk, right? Here, so we know that here, this is h, and then over here is k, right? So the vertex, which is the middle of your absolute value function, is just 0, 0. So you're going to plot 0, 0 right here. And we know that the slope is 1, right? But also the axis of symmetry. So one thing that you have to remember also is that the axis of symmetry, which basically divides your absolute value function, or your v-shape, it divides it into two linear equations. You would say that the axis of symmetry, so is x equals 0, or x equals h, which is 0, right? That is what your axis of symmetry is. You can label it like this if you want. Right here, you can label your axis of symmetry. You can say that this is x equals 0, right? Which is your axis of symmetry, if that really helps. Now, because you know that it goes at 0, 0, and you know that your slope is 1, your slope is right here. This is your slope. So what does that mean? That means that rise over run is 1. So you can do it from the right side. You can go, so you can go up 1. My bad, guys. Give me 1 second. Go up 1 to the right 1. So right here, right? So it would be right here. And then again, you go up 1 to the right 1. So right here, and then again, up 1, right 1. And since it ends at y equals 3, you can stop there. However, don't forget that also you have to reflect it across the axis of symmetry. So the reflection, and you have to be good at reflections for this. If you remember from geometry, you have to reflect across the y-axis. In this example, okay? So reflecting across the y-axis, that means that if I have this point here I have this point right here, I'm gonna go 1 unit left and then another unit left to reflect across this line here. Because this is my axis of symmetry, right? So I'm gonna reflect it and I'm gonna end up right here. And again, I'm gonna do it again for where x equals 2. I'm gonna go 1, 2, and then I'm gonna do it again. I'm gonna go 1, 2. So I'm gonna end up right here, okay? And then I'm gonna do it again for x equals 3. I'm gonna go 1, 2, 3, and then I'm gonna do it again. 1, 2, 3. So I'm gonna end up right here, okay? And you see how it gives us the exact same graph as it did when we did the table form. So there are different ways in which you can do this. The only thing is that if you are in college algebra, I mean, I will say that usually they would ask you to state the vertex. If they give it to you in vertex form, they would ask you to state the slope, the vertex, and so, but if you're in high school, you can do it just either using table of values or by using vertex form. To be honest, I like to use vertex form just because that is the more, I feel like that's the more college way of doing it. But like I said, you can use, if you're in high school, you can use table form if you really don't understand how to do it using vertex form. But it's very important that we push ourselves to understand both forms, or both ways of graphing this. So we're going to look at some other ones now, and let's see. So if we do, for example, let's just kind of do another one. So y equals -2 times the quantity, or times the absolute value of x minus 1 plus 1. And so I'm gonna go ahead and draw my graph, so give me 1 second. So let's say we have this one, and this is gonna be the last one of this video, because I already know time passes by so fast, and I don't want to do too many of these, but this is one where so basically we have this in vertex form, and this is obviously the only form that there is, but we're going to first graph this using an XY table. Now, let's say that because we have all the way, down to -5, we can do -5, and then -4, -3, -2, -1, 0, and then let me make it a little longer. 1, 2, so 3, 4, and 5, okay? Now, obviously, it's going to go, when we do it for -5, it'll probably go, like, off the scale, but I'm only going to graph the ones where I can plot it on the coordinate plane. So if I make x equal to -5, so let's just rewrite this as f of x equals -2 times the absolute value of x minus 1 plus 1, right? So here I'm gonna make, let's say I do f of -5, and let me color code this so that everyone can see what I'm doing. So f of -5, and I say this is -2 times the absolute value of -5, and it's going to be -1 plus 1, right? So this gives me -2 times the absolute value of -6, because -5 minus 1 is -6, plus 1. And then you ask yourself, what is the absolute value of -6? That's just 6, right? Plus 1, so this equals -2, or I'm sorry, this -2 times 6 is -12, and then plus 1, that's just going to be -11, okay? So obviously it goes off the grid, but we can still put it in the table. Now what if we do -4? If we do -4, so f of -4, and do the same thing, we can say this is -2, and then right here, so again, I just want to label that right here is our function so that you guys can see what I'm doing. I'm going to plug -4 in for x, so I'm going to say -2 times -4 minus 1 plus 1, right? So I have -2 times the absolute value, and then I have -4 minus 1, that's -5, so I close my absolute value symbol, I put plus 1. So then I have -2, and then what is the absolute value of -5? That's just going to be 5, and then plus 1, which is going to be -10, plus 1, which is -9. I'm going over this really slowly for those that are not good at these, so bear with me. And then let's do f of -3. What is f of -3? F of -3, oh, and by the way, you can put that in for x equals -4, it's going to be -9. F of -3 is going to be -2, and you're just going to plug in -3 for x, because right here is our function, right? So you're going to do the same thing again. Plug in -3 for x. So you have -3 minus 1 plus 1. This is -2 times the absolute value of -4, because it's -3 minus 1 is -4, right? And then plus 1, that's just going to be, so basically we have -2, and then the absolute value of -4 is just 4, plus 1, that'll be -8, so -2 times 4 is -8, and then plus 1, so -8 plus 1, that's just -7. And again, it goes off the grid, which is fine. But do you see a pattern? It keeps decreasing by 2. But you have to be careful. And that's kind of why you have to keep, if you like doing it by table, then that's okay, but it just takes a little longer depending on what you plug in for x and y. Now let's do f of negative 2. So f of negative 2 will be negative 2 times the absolute value, and again, right here is our equation, so I'm going to say negative 2, because x equals negative 2, right? And minus 1 plus 1, right? So I'm going to say negative 2 times the absolute value of, and then what is negative 2 minus 1? That's negative 3, right? Plus 1. So then this gives me, so then we have negative 2, and then I have, what is the absolute value of negative 3? That's just going to be 3. And then plus 1, right? So then this gives me, so then what is negative 2 times 3? That's negative 6 plus 1. That's going to be negative 5. So when x equals negative 2, y is equal to negative 5, right? And we still can't plot it because you see we don't have a negative 5 here. It's, when I drew this graph, I guess I didn't, I didn't do it in the right scale, but we're going to get there, right? And I'm doing this very slowly because I don't want to speed up a little. I don't want to speed up too much. So f of negative 1 is going to be, so we're going to do it again, negative 2 times the absolute value of negative 1 minus 1 plus 1. So then I have negative 2, and then I say, okay, what is negative 1 minus 1? It's going to be the absolute value of negative 2, right? And then plus 1. So this equals, I have negative 2, and then what is the absolute value of negative 2? This is going to be 2 plus 1. So then what is negative 2 times 2? That's negative 4 plus 1. What is this going to be? This is negative 3, right? So we have, when x equals negative 1, we have y equals negative 3, right? Now what about when x equals 0? So we have f of 0 will be equal to negative 2, and I'm going to do times the absolute value of 0 minus 1 plus 1. This is going to give me negative 2 times the absolute value. And what is 0 minus 1? That's just negative 1, right? So we have like this, plus 1. And then this is going to be equal to, so what is the absolute value of negative 1? That is going to be, so we're going to have negative 2, and the absolute value of negative 1 is 1 plus 1. And this is going to give me negative 2 plus 1, which is negative 1. So when x equals 0, y equals negative 1. Okay, and then what about when y equals, or when x equals 1? If I do, again, I'm going to do f of, so I'm going to do f of 1, and I have negative 2 times the absolute value, and I have my, it's x minus 1, so I'm going to say 1 minus 1 plus 1, right? So this is going to give me negative 2 times the absolute value, and then I have 1 minus 1. How much is that? That's just 0 plus 1, right? So that'll be negative 2, and then what is the absolute value of 0? That's just going to be 0 plus 1. And then what is negative 2 times 0? That's 0. And then plus 1. What is 0 plus 1? That's just 1. So when x equals 1, y equals 1. And you just keep going, and we're going to keep going, right? We have negative 2, so times the absolute value of, and again, I'm going to do f. It helps if you keep writing your function. So then you're going to say f of, unless you are good at looking at it, you know, from your page, from the paper that you have. So when x equals 2, we're going to do f of 2, right? F of 2, and let me color code that. Is equal to negative 2 times the absolute value of 2 minus 1 plus 1. This will be negative 2 times the absolute value, and I'm going to say 2 minus 1, that's just 1, plus 1, right? This is equal to negative 2 times 1 plus 1, which is really just negative 2. So, you know, obviously the absolute value of 1 is 1. 2 minus 1 is 1, so then, you know, this is why I put it like this. Negative 2 times 1, that's negative 2. And then we add a 1 right here. And then what is negative 2 plus 1? That's negative 1. So when x equals 2, y equals negative 1. Now what about when x equals 3, right? Negative 2, so again, f of x equals negative 2. F of x, so sorry guys, give me a second, I don't know why it did this, hold on. So give me 1 second, everybody. Okay, so we have f of x, and again, like I said, if it helps writing your function over and over, that's okay too. We're going to do it that way. So negative 2 times the absolute value of x minus 1 plus 1, right? And then we have, this is going to be, so when we plug in a 3 for x, we're going to say f of 3 equals negative 2 times 3 minus 1 plus 1. And then I say, okay, this is just, I'm gonna keep my negative 2, and I have, what is 3 minus 1? That's just gonna be 2 plus 1, right? And then what is the absolute value of 2? That's just gonna be negative 2, and then I'm gonna say the absolute value of 2 is just 2, right? Plus 1. And then I'm going to say, okay, what is negative 2 times 2? That's just negative 4, and then plus 1. And then what is negative 4 plus 1? That's just negative 3, right? So when x equals 3, y equals negative 3. And then what about when, so what about when x equals 4, right? Again, I'm going to write, and again, if it helps, you don't have to do this, but like if you have your function right in front of you and you know how to do it without rewriting your function over and over, that's okay. If you need to write your function every time you do this, that's okay too. We have negative 2 times the absolute value of x minus 1 plus 1, okay? So we're going to say f of 4, that's going to be negative 2 times the absolute value of 4. We're going to plug in a 4 for x, minus 1, plus 1. So then we have negative 2 times the absolute value of 3, because 4 minus 1 is 3, right? So then we have plus 1. And then we go ahead and say, well, this is just negative 2, and then I say the absolute value of 3 is 3 plus 1. This is going to be negative 6 plus 1, which is, because 2 times 3 is 1. I mean, 2 times 3 is 6, excuse me. And then plus 1. So then it'll be, so negative 6 plus 1 is negative 5. So that's what f of 4 is. So when x equals 4, y equals negative 5. Now one more, and I will do this also by Vertex Form, and then that'll be it for this video. So f of 5, if I do f of 5, I'm going to rewrite my function, f of x equals negative 2 times x minus 1 plus 1. So f of 5 is equal to, so let me color code again, f of 5 is going to be negative 2 times the absolute value of 5 minus 1 plus 1 f of, so this is going to be equal to negative 2 times the absolute value, and then 5 minus 1 is 4, and then we're going to add 1 right here. Now what is the absolute value of 4? That's just 4, right? So we're going to say negative 2 times 4 plus 1. This is going to be negative 8 plus 1, which is going to be negative 7. Okay, so when x equals 5, y equals negative 7. Now let's go ahead and plot these, right? And like I said, sometimes an XY table takes a lot longer, or most of the time it takes a lot longer than doing it by Vertex Form, right? So we have negative 5, negative 11. Obviously, negative 11 goes really low on the grid. So if you kind of look at your minimum for the y value, so here's the y-axis, and the minimum, meaning that the lowest point is negative 4, and the highest point is 4, right? So you can go, so basically, you can do from, so actually, hold on. You can do from, because your lowest y value is negative 4, negative 5 is not on the grid. We can't do negative 5. So we're going to go from negative 3 and then all the way up to maybe, so like basically these 3 here, or these parts. So we can plot, so obviously even if you look at your XY table and you're like negative 5, negative 11, you're going to be like, oh, well, I don't have negative 11. I have all the way to negative 4. And you're going to keep going until you finally find a number where you can plot it on the coordinate plane. So here we can plot negative 1, negative 3. You don't have to know right away how I did it like this. It's not important, but you can go ahead and plot. You can go like from, you can start here and then keep going until you finally find a number or a point that you can plot on the x and y plane. So we have negative 1, negative 3, and then we're going to have 0, negative 1, and then we're also going to have 1, 1, and then we're going to have 2, negative 1, and then we're also going to have 3, negative 3, and that's going to be kind of the the end of it, right? And we can do it like this, and because we know that, it's gonna look like this, right? And then also, because it forms an upside down V, right? Now this is if you graph it without using the vertex form. And like I said, guys, doing it this way actually takes a lot longer, in my opinion. If you like doing it this way, that's great, but in my own opinion, it takes a lot longer than doing it in vertex form. So we're going to do it in vertex form this time, so give me 1 second, and then that'll be it for this video. Alright, so let's look at this now in vertex form. This is, just in my opinion, guys, doing it this way is a lot quicker. But like I said, if you don't like it in vertex form, if you don't like doing it in vertex form, and if you don't like graphing it without doing an XY table, that's really up to you. But I really find this to be the quicker way. So, again, I'm going to go ahead and label, or I'm going to go ahead and write the equation of an absolute value function in vertex form. So we have A times the absolute value of x minus, it's going to be h plus k, okay? Here, your A is -2, right? Because right here is where your A value is. Your H is right over here. And then your K value is right over here, okay? So, in reality, so let me go ahead and write that down. So we have H, right? We have H equals 1. And then we have K is also equal to 1. So the vertex is HK. That is the middle of your V shape, or your upside down V shape, whatever it's going to be, right? And also notice that A is less than 1, or I'm sorry, less than 0. So in reality, we're going to have a graph that is pointing downwards because A is less than 0, right? So we already know that it's going to be pointing downwards. So the vertex is going to be HK, right? So it's going to be H, comma, K. And then the slope, which is your A value, is going to be -2. And your axis of symmetry is going to be x equals h. So, like this, right? Now, we know that the axis of symmetry is x equals h, and that's really just x equals 1. So we have like this, right? So we're going to go ahead and kind of draw a dashed line at x equals 1, right? So, like this, right? And then wherever, so let's see here. And then we know that at x equals 1, basically the vertex is at x equals 1, and when x equals 1, because over here k is equal to 1, our vertex is going to, again, it's HK, so it's going to be 1, comma, 1, right? So your vertex is going to be right here. Now you're going to follow your slope, but you're going to do it on one side of this dashed line. So you're going to say, so the slope we said was -2, that's rise over run. So you're going to go down 2 and to the right 1, right? 1, 2, 1, and again, 1, 2, 1, and then again, 1, 2, 1, and it goes kind of off the grid, but you don't have to include that last point. But in reality, that's how it would be. And I'm only showing these little curves here so that you guys can see how exactly I'm doing it. And now because this is our axis of symmetry at x equals 1, right? We have to reflect these other 2 points in where it's 2, -1 and 3, -3, right? So we're going to go ahead and reflect. So what does that mean? We're going to go left 1, and then we're going to go another 1 unit again. So it's going to be right here, right? And then again, we have at x equals 3, we have a reflection again, so but this time we're going to go 1 like this, and then again, so we have 1, 2, and then it's going to be, this is the reflection again, this is our main line of reflection, so we're going to reflect again 2 units, 1, 2, right? And once you do that, you don't have to have these little curves anymore, so you can take them off. But you've already plotted enough points to draw your upside down V shape. So in reality, you can keep, I mean, I don't know, it depends on your college or your professor, your teacher, whether or not they want you to keep this line, this axis of symmetry. But that axis of symmetry is mostly just to help you. It depends on them whether or not you want to keep it. You can ask them if it is okay to keep the axis of symmetry on there, and if they ask you to take it off, then you must take it off. But you can always just do, so you can always just, you know, do without it. It doesn't really matter. But it really depends on your professor. I would always ask first. So that means that we're going to have a line going from here to about here, right? I always go a point, like, I always go a little further after the last point that I plotted, because that way I can draw my little arrow saying that it's going to go downwards on this direction whenever x is greater than 1, and then it's going to go downward when x is less than 1, right? So I can do it like that, and this is how it's going to look in reality, right? And as you can see, I do believe that it is the exact same way that it looked when we did it without, or with using a xy table. So this represents f of x equals -2 times the absolute value of x minus 1 plus 1. And that is how you graph both these absolute value functions with and without an xy table. So with that being said, guys, I know I went very slowly in this video. and it was for a really good reason. I want to try to go as slow as possible so that those of you who don't understand or are not really good at these can really benefit from this video. I can do a more faster one, but I really kind of want to go as slow as I can because I feel like if I go fast, I might make mistakes. But with that being said, guys, thank you so much for watching. Please like, comment, and or subscribe, and I will see you guys in the next video. Bye, guys.